Wow, this is the third session on drilling on the lathes. You know, drilling is one of those fundamental tasks which just adds so much depth to the type of projects. Well, that was a pun. Depth to the type of projects that you can actually make on the lathe. And you know, we've covered a lot so far. We've talked about sharpening drill bits. We talked about how to maintain your quill. We've talked about how to change a Morse taper. We've talked about drill chuck selection and a host of other items of specific knowledge. But as I went back and reviewed everything, there is a couple of one specific thing that I wanted to address a little bit better, and that's the importance of your center line. It's critically important that your center line be accurate for your lathe, so that when you have something in the headstock and in the tailstock, when they come up, they're actually smack on in alignment with each other. Now, to check that a little bit better than using tongue depressors, we're going to actually bring them up close, lock down the tailstock, and then slowly advance the quill. And what we're looking at is right here. And it's a little bit difficult to get you in far enough to see it all the way, but we'll try. If you look, that needs to meet head on, and it doesn't. Well, the reason it doesn't is I haven't fully seated it in the tailstock. Now when we bring it up and we look at it, what we find that it's dead on. Now it's important that it be dead on, not only in this fashion, but also in this fashion. So if we look here, it should be they should be just touching each other. If we look from the side, they should be touching each other. If you have that, then you have a perfect alignment for drilling, which it really can get important, because if you come in off and you end up actually making an oval hole. You don't know how else to say it. It just is not a good thing. Now, if you're slightly out of alignment, where you actually correct the problem is on the lathe and the stand. So you're going to go back and you're going to loosen the bolts that hold the lathe to its stand. Not take them out, but just loosen them. And allow the lathe to come up and to find its own level spot. Then go back and look at each of your leveling locations. And what you want to do is, if there's any gap in there, to shim it. Now, I don't care whether you use shimmy material, brass shimmy material, or you use thin washers or thick washers, but whatever you do is that you want to shim it and then snug it back down again. Now, if you're in a position where the lathe doesn't move, you're going to do it one time. But if you are in a situation where you're having to move your lathe in and out of a garage or back in the center of a floor, get it where you normally use it. Go ahead and get it leveled properly with the shims, and then mark a place on the floor where you've set that lathe up for, and then you're good to go. It is my belief that if you understand a rule, somehow or other it just sits better in our minds, and we're more inclined to actually remember it and do it when we need to. So let's talk a minute about what's been happening as we've drilled. What we have is we have a piece of wood, and we have a hole that's in that piece of wood, and we have a drill bit that's coming in and it's forming that hole. Now, as it does it, what happens is the area behind the drill bit starts getting full of shavings. And what will happen is there's always heat when you drill. And the heat on the wood will make the wood expand, because there's always a little bit of moisture in the wood. And when it expands to the point where it becomes a block, guess what happens? Now, when we go over and we take our tailstock and we try to put it back this way, what happens is the tailstock moves and the drill bit stays in the wood. And when that happens, when the drill bit and your Jacob's chuck stay in the wood, that's when you get that horrible nasty that I had, where all of a sudden what you're looking at is a drill bit that looks like this. Why'd that happen? Well, Didn't clear the shavings. So it's horribly important to clear the shavings, clear the shavings, clear. If you'll notice me, I kind of have a tendency to count 1, 2, 3, 4, 5, clear. 1, 2, 3, 4, 5, clear. The rhythm to it just kind of helps me stay in the safe mode. Or if you know a song, stay, clear in time with the song. Doesn't make any difference how you manage to do it, but be sure you clear, because if you don't, those shavings will build up. They will expand, they'll create a dam, and now when you go to pull the tailstock back, you have all sorts of nasties. Now, if you have your hand on that drill chuck, because unconsciously you're aware of this problem, all you're going to do is have your hand in the middle of a very bad nasty. So, clear. Okay, it's actually time to drill a piece of wood. Turn on our lathe, and we're going to face off where we're going to drill. Now, the reason for that is if this is uneven, unlevel, as you come in, you're going to have a tendency to have more problems with this. Second step is to come in and actually mark the center point of the lathe itself. Now, you can use a whole bunch of different tools. Really, the right one is whatever you got handy. This is a 3-point tool. This is a Bedan. All they really have is the point. That's what we're after. And what we want to do is bring this up, and we want to make sure that the point of the drill, when it comes in, has a natural place to start, a point that is dead on the center line, because that's really important. Now, with that done, we're going to move the banjo, take the tool rest off. We're going to take our drill chuck. In this case, again, I'm using the one with a short distance. I put it in, bring it out so that it firmly seat. Now, there's a lot of little things involved, and when you do them all right, this just goes really well. If you start getting hurried or you try to skip the little things, what happens is all of a sudden you end up with that bent drill bit that I had years back, and I don't want you all to get there. So pay attention to the little things. The next little thing we're going to deal with is right here. We're going to bring up the tailstock. I'm going to lock it down, and I'm going to take the hand wheel, and I'm going to advance it. Now, the reason for doing that is that when I advance that and put some pressure on the wood with the lathe off, everything gets seated. The point goes in dead on the center line. The drill chuck gets firmly seated in the quill of the ways. And then we back it back off just so it's right there. Now, the interesting thing that happens is I have seen people, when they get to this stage, what they begin to realize subconsciously is that maybe that's not quite centered. So to help them find that center point, what they'll do is they'll put on a glove, and they'll come up and hold that to kind of make sure that it goes into the center point. Now, as soon as I see a glove around a lathe, I have these shivers go up and down my spine. It just is an accident waiting to happen. The glove may protect your hand, or it may get wrapped around something and bring everything in. I am not a fan of, really what's happening is subconsciously we begin to be uneasy. Well, so you reach for a Band-Aid, but it's like putting a Band-Aid on a broken leg. It doesn't work. So if you've done the little things, you really don't need to put your hand, because you've firmly seated everything. You've got a center hole right smack on the center line. Now we're ready to go, but we have a question before I turn on the lathe, is what speed should it be set at? And my answer to that is I have a chart right up here on my bulletin board for various different types of wood and what the recommended maximum speed is on your lathe for bit sizes. But my stubby actually doesn't have any RPM indicators without me getting down on my knees and crawling around the backside, which I don't want to do. So I kind of do it by ear. But the key is it's generally a little bit slower than you might think. So we're going to turn on the lathe, bring it up to speed, check, make sure that's loose, get the gloves out of the way, bring it up, And here we go. Oh, I love it. Oh, I love it when those shavings come out like that. Now, what I'm really going to do is go ahead and do this. Just turn and turn and turn until the drill bit is no longer visible. So if I look at where I am right now, what I've done is I've gone in until the drill bit is now, the outside flange of the drill bit is seated right at the wood. Now at that point I'm going to change what I do. I'm going to back it out just a tad, turn on the lathe, bring this in, and I'm going to start to count. 1, 2, 3, 4, 5. Then I'm going to back it out. Backing it out is hugely important. We're going to focus on that in a couple of minutes, but it's just like going through butter. Love it. Why is that so easy? Well, the reason it's so easy is sharp drill bit, clean quill, good equipment, and it's all the little things that we've talked about. Here we go back in again. 1, 2, 3, 4, 5. Not forcing it, but this is just working so beautifully I can't understand. I can't believe it. Chalk that up to luck, shall we? In any case, no, I really am serious. It's all the little stuff makes it easy. If you try to run too fast, if you try to skip the little things, it comes back to haunt you really, really very badly. So that's the basic drilling operation. Now we're going to get into some interesting stuff. Another very frequent usage of drilling techniques and drill bits is actually to find the bottom as a depth stop. When you're making a hollow form, or whether you're making inside of a bowl and you want to set the depth, how far do you want to go in? And the way this works is we take this, which is what they refer to as an aircraft bit that's readily available at different hardware stores. It looks like this, unhandled. They're not really expensive. This particular one is 12 inches long, and what I've done is I've put it into a handle. Now, if you look closely, you're going to see that this is the smallest diameter aircraft bit. This is slightly larger, and this is larger. You know, it's very important that your handles be of a size to the diameter of the bit, because as your bit diameter increases, the rotational forces involved increase, and you need the leverage of a bigger grip to be able to stay comfortable and safe with it. But here's how we use that. Same way we started before. We're going to face off our blank just to make sure that it's true. With that done, we're going to set our point, set our dimple, so to speak, by just putting a little thing right there. Now, I'm going to back up the tailstock, or the banjo a bit. I'm going to take my aircraft bit, my handled aircraft bit. I'm going to find that dimple. Now, what I want to have happen is I want my tool rest to be, now we got to go back here, perfectly leveled. And if I look at that, it's a little bit high. So I'm going to take it, I'm going to lower the tool rest just a scooch, come back in here and go like this. Now, I can turn on the lathe, find that dimple, push in, 1, 2, 3, clear, 2, 3, clear. And I tap on the tool rest to make sure that I've cleared. Now, the secret to it is to take your blank and mark where you want the bottom of your form to be. Come back with this and take a piece of tape. You notice I've got some tape around the handle just so I always have some. And we put a drill bit up and we say, I want it to go to that depth. So now what we've done is we've marked our depth. Turn the lathe back on. Come in. Boom. boom, 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 boom. And we set the bottom, the depth of our bowl or hollow form. Sometimes what will happen is that you'll unfortunately not be on that exact center line, and as you go deeper and deeper and deeper, little deviations make it, starts to be off center. There's really nothing you can do about that other than to take it back out, hollow down to where the hole stopped, and then reset your hole and do it again. Typically what I do is I just leave it alone. It's when I get down there I'm going to fight it a little bit, but I'll get rid of that nub down there. But it helps you to know exactly where you want to set that bottom. Now this is the kind of one that I would use for a bowl. But if I'm going to do a Christmas ornament, something smaller as a hollow form, I would probably do something like this. Much smaller drill bit, a much smaller length. I just don't need all that length. It's simply epoxied into a wood handle. So that's aircraft bits. Next, I'd like to introduce you to what's called a gun drill. It looks like this. And what we have is the bit itself, which is long. It actually comes from the metalworking industry. It's designed to drill out the bore of a firearm. Then we have it mounted into a shop-made aluminum handle. It could just as easily be wood. It's epoxied in with a couple of set screws. Very important is that you have a control valve down here. Now, the way this works is there's a couple of parts here that are really important. So let me bring you in as close as I can get you. What we have is a long, thin piece of metal that has had a channel right here in it. And at the very tip, what we can see, there is a hole that runs the length of the bit. And the way this would work is that drilling fluid would come out of this hole and then be returned, after it cools the bit, returned up this channel in the gun drill. Now, when we do it in woodworking, it works the same principle, but the difference is instead of using a drilling fluid, what we're going to use is air. Now I'm going to take the air connection, put it on here, make the connection. Now it's very important that you have this control where you can keep the amount of air that's coming through under control. If you get too much, it's going to cause you kind of problems. But here we go. Now, the way it works is same as we had shown before. We're going to start by going to the center of our piece and making sure that we have a center. Once that's established, I actually don't need that. And so we'll move it back out of the way. Turn our lathe, get it up to drilling speed, and simply come in, put the point in the hole, put the point in the hole, turn on a little bit of air, and simply push. And what happens is the air clears the wood so we don't have to back it back out. Now, what you do have to be careful with is that if you have the air full on as you drill and you have your head anywhere around, like this, what you're going to do is you're going to end up with a blast of those shavings come back and hit you in the face. One drilling technique that used to frustrate me is to try to put hooks in Christmas ornaments. If you didn't pre-drill it, what would happen? Of course, the finial would crack and you'd wasted the whole effort. So I went out and I got some small drill bits like this, and I epoxied them into a handle so I could just go zip and be done with it. Well, that works pretty well, except for one thing. When you buy drill bits this small at the hardware store, they're hard to find. You got to go over the metalworking bits, area or metalworking area and get introduced to drill sizes that are numbers and letters. I mean, it's just a different world for me anyway. But never buy one. Always buy a dozen or 2 dozen because they break really easily. And, you know, you go to all the trouble to get them in a nice wood handle, and the next thing you know, they break off and they're done for. So I said, it's got to be a better way to do this. So it works really fine on a larger diameter bit, little handle. So if you got to drill some smaller holes, that's just a quick, easy way to do it. No drill chuck involved. But I got tired of breaking those small ones when I'm making Christmas ornaments, so I figured there had to be a better way. What I finally came up with is a very expensive solution, only because there's a lot of trial and error to it, but it's an X-Acto knife. And what I've done is I've used the collet of the X-Acto knife to hold in place a small bit of wire that's the correct size to pre-drill for my eye hooks on my Christmas ornaments. And really, you know, you just take it, you get some stuck in there, and you clip them off with a pair of electrical clippers, and it's kind of sharp, it's enough, but when you go to drill, all you have to do is go, boom, done. Now the nice thing about it is that if by chance it gets bent, all you have to do is straighten it back out. If it finally does break after too many bends because of metal fatigue, you just pull out another length and keep going. So the thought is, I'm going to use a thin wire that's properly sized for my eye hooks on Christmas ornaments. I'm going to hold that wire in a small collet. Now, there's lots of different things that have small collets to it. I found the X-Acto knives work really well, but so does the small rotary bit on my Fordham, the small one. But this is a lot less expensive than the other one, and I can replace that without any problem. So anyway, that introduces you to the concept of drilling small holes. We've covered a lot of topics on these 3 sessions about drilling. Does it make all these little things make a difference? They sure do. And as a final thought, if you found this worthwhile, please do give me a thumbs up. I will respond to any comments. If there's some drilling technique that I haven't talked about that you should be included, please let me know.